everyone. Today we have to discuss about relation between change in enthalpy and change in internal energy. Already he knows enthalpy equal to sum of the internal energy and pressure into volume. Okay, now change in enthalpy equal to change in internal energy plus change in pressure into volume. Here, change in pressure into volume equal to P del V or V del P. Okay, from ideal gas equation, P del V equal to del N naught T for N moles. So here, apply here. So del H equal to del U plus del N naught T. Here, del N means change in number of moles. Del N means change in number of moles. Del N equal to number of moles of products minus number of moles of reactant. Del N means change in number of moles. So del N equal to number of moles of product minus number of moles of reactant. Okay. Now we have to apply some reactions, different cases. First one, case one. Whenever number of moles of product equal to number of moles of reactant. In those reactions, number of moles of product equal to number of moles of reactant. For example, H2 plus I2, 2HI, all are gases only. Okay, now del N equal to number of moles of product minus number of moles of reactant. 2 minus 2 equal to 0. Del N equal to 0. Now, del H equal to del U plus del N naught T. Here, del N equal to 0. That's why del H equal to del U curve. That means, in those reactions, number of moles of product equal to number of moles of reactant, change in enthalpy equal to change in internal energy. Okay? Next one, case 2. Whenever number of moles of product more than number of moles of reactant. Number of moles of product more than number of moles of reactant. For example, PCl5 phosphorus pentachloride dissociation to phosphorus trichloride plus chlorine gas. Okay. Now del N equal to Np minus Nr. Product how many moles? 1 plus 1, 2. Reactant 1 mole. 2 minus 1 equal to 1. Del N equal to 1. In this case, del H equal to del U plus del N naught T. Here del N equal to 1. That means del H equal to del U plus RT. That means here change in enthalpy equal to change in internal energy plus RT. That's why a change in enthalpy greater than change in internal energy. That is the whenever number of moles of product less than number of moles of reactant, number of moles of product less than number of moles of reactant. For example, N2 plus 3H2 gas equilibrium 2NH3. N2 plus 3H2 equilibrium 2NH3. Okay. Now del N equal to number of moles of product minus number of moles of reactant. 2 minus 4 equal to minus 2. Now del H equal to del U plus del N dot T. Here del N equal to minus 2. That's why del H equal to del U minus 2 RT. So here change in enthalpy equal to change in internal energy minus RT. That's why here change in enthalpy. That means change in enthalpy equal to change in enthalpy value subtract from change in internal energy. That's why del H less than del U. So when in those reactions number of moles of reactant more than number of moles of product, del H less than del U. Del H less than del U. So these are the three cases. So exam you should observe. So based on the reaction, del N value change. Next, another important terms. Heat supplied at constant volume. Heat supplied at constant volume equal to QV. Heat supplied at constant volume QV equal to change in internal energy. Okay, heat supplied at constant volume means del U. Remember, internal energy. Heat supplied at constant value means internal energy. Next one, heat supplied at constant pressure. Heat supplied at constant pressure. This is a constant volume. Okay, equal to QP equal to del H. So these two are very important. Simple remember, amma. Heat supplied at constant value means internal energy. Heat supplied at constant pressure means enthalpy. Okay, now heat supplied at constant volume, heat supplied at constant pressure. Okay, these 2 points should be remembered. Then write down one problem. The heat of reaction for C10H8 butanol solid plus 12O2 gives rise 10CO2 plus 4H2O, oxygen gas, carbon dioxide gas, water aqua liquid, water aqueous solution liquid. What I say, what is the condition for calculation of del N? Whenever solids and liquids come in reaction, ignore while del N calculating. While del N calculating, solids and liquids ignore. You should calculate only for gas molecules. Understand now? That's why C10H8 number of moles ignore. 4 moles of water also ignore because this is solid, this is liquid. Solids and liquids number of moles should be ignored. only calculate gas molecule number of moles. Okay now. H2O at constant value means at constant volume. At constant volume means already I said at constant heat of the reaction. Heat of the reaction means heat supply. Heat of reaction at constant value means internal energy. Change in internal energy is minus 1228 kilojoules. Kilojoules. Calculate the heat of reaction. Calculate the heat of reaction at constant pressure. At constant pressure. At constant heat of reaction at constant pressure means enthalpy. Heat of reaction at constant pressure means enthalpy. Okay, at 25 centigrade. At 25 centigrade. Okay, R value. This is kilocalories. Okay, kilojoules also take, no problem. Kilojoules take. Right, at 25 centigrade. Now write down formula. Del H equal to del U plus del N naught T. We have to find out del H. Del U value they given minus 1228 kilojoules. Del N value we have to find out. Number of moles. Change the number of moles. Del N equal to solids and liquids ignore. So product how many moles? 10. 10 minus 12. Reactant to 12 moles equal to del N equal to minus 2. R value here kilojoules now. That's why R value should take as a joules because internal energy change value they given in kilojoules. That's why R value should taken as a joules. So units unique is very important. If here kilojoules given, if you take R value calories means wrong answer come. Here joules given means so R value also you should take joules. If here heat energy calories given means R value should take as a calories. Okay, depend on the heat energy R value you have to take. Okay, different to take means wrong answer come. R equal to 8.314 joules. Temperature 25 centigrade converts to kelvins. 273 plus 25 298 kelvins. Okay, temperature should convert to the in the form of kelvins. Now del H equal to del U value minus 1228 kilojoules. That converts to joules. Kilojoules converts to joules. That means into 10 power 3. Because R value taken in joules now. That's why kilojoules converts to joules. That means into 10 power 3 you take plus here N value how much? Minus 2. Minus 2 into R value 8.314 into 298. This is the answer. Do calculation. Answer come. Okay. So here you should understand first of all in this problem, whenever find out del N value, whenever you have to find out del N value, solids and liquids ignore. Only you have find out number of moles of products minus number of moles gas molecules only. Only gas molecules only you can calculate. First step. Second one, heat of reaction at constant value means internal energy. Heat of reaction at constant pressure means enthalpy. Okay, then here heat energy values whether internal energy or enthalpy. Okay, whether internal energy or enthalpy. Heat energy values units should be equal to R value units. If heat come. Okay, this is the one sum. Next, another one sum, right? Another one sum. For the reaction at 25 centigrade, another sum. For the reaction at 25 centigrade, NH3 dissociation to NH3 dissociation to half N2 plus 3 by 2 H2. Okay, for the reaction at 25 centigrade, NH3 dissociation to half N2 plus 3 by 2 H2. Calculate del E for the given reaction at 25 centigrade. Given reaction at 25 centigrade. Del H naught equal to 11.04 kilocalories. Del H equal to 11.04 kilocalories. Okay, so we want to find out change in internal energy. They given change in enthalpy values. That's why del H equal to formula del U plus del nRT. Del H equal to del U plus del nRT. Okay, we should find out del N. Del N equal to 1 by 2 plus 3 by 2 minus 1. Okay, all are gases only. That's why all are considered only. 1 by 2 plus 3 by 2 minus 1. Okay, 1 by 2 plus 3 by 2. Here 2. That means here 4 by 2. That means 2 minus 1. 2 minus 1, 1 come here. 2 minus 1 equal to 1 come. Here del N value 1 come. Okay, now del H value they given. Now del U equal to del H minus del nRT. Okay, now del U equal to del H value how much they given? 11.04. 11.04 minus del N value 1 into here kilocalories given now. That's why R value should taken in calories. That means R equal to 2 calories. R value stable values, constant values. R equal to 2 calories. R value real gas constant. R equal to 2 calories. So here this kilocalories converts to calories. That means 1 kilocalorie equal to 10 power 3 calories. 1 kilocalorie equal to 10 power 3 calories. Already knows. So 11.04 into 10 power 3 minus del N value 1 into R value 2 calories into 25 centigrade means 273 plus 25 298. The answer come. So this type of problems come. So you should find out del N value first of all. Second one, here heat of energy in the form of kilocalories. That's why R value should take as a calories value only. So kilocalories converts to calories. So 1 kilocalorie equal to 1 kilocalorie equal to 10 power 3 calories. 1 kilocalorie equal to 10 power 3 calories. All values substitute, answer come. Next, another one problem item. Right. At 27 centigrade, the internal change of reaction, value of the reaction, internal change of the reaction, H2 plus Cl2 gives rise to HCl is 2 kilocalories. 2 kilocalories. To find out the del H of the reaction. To find out del H of the reaction. Okay. First you have to find out del N. Del N equal to 2 minus 1 plus 1 2. 2 minus 2 equal to 0. Okay, now del N value 0. Here internal energy value is in kilocalories now. That's why R value should take calories. R equal to 2 calories. Here del U value converts to calories. Then change in energy 2 kilocalories now. 2 kilocalories converts to calories. 2 into 10 power 3 calories. Okay. Now find out del H. Del H equal to del U plus del nRT. Okay. Here del N value 0. Here del N value 0. That's why 0 into RT 0. That's a direct common. Without calculation, this problem you have to do it. Without calculation, this problem you have to do it because del N value 0 now. 0 into RT 0. That's why here del N equal to 0. That's why whole value 0. Now del H equal to del U. That means internal energy value how much? 2 calories. That only enthalpy value. That's why del H equal to 2 kilocalories. Del H equal to 2 kilocalories. So like that problems coming up. So then discussion class I will give some more extra problems. Then in reference books also you have practice some sums. Next one, heat capacity. What is the heat capacity means? The heat energy required to temperature rise of the given amount of the substance by 1 centigrade or 1 Kelvin. 1 centigrade or 1 Kelvin. That is called heat capacity. Heat capacity represents by capital C. Heat capacity represents by capital C. So heat capacity equal to capital C equal to, okay, so heat energy required dQ by change in temperature dt. the heat capacity. Next one. Next one. Molar heat capacity. Molar heat capacity. Molar heat capacity represents by Cm. M means molar. C means heat capacity. What is the molar heat capacity means? The heat energy required to rise the temperature of 1 mole of the substance. Rise the temperature of 1 mole of the substance. 1 mole of the substance by 1 centigrade or 1 Kelvin. 1 centigrade or 1 Kelvin is called molar heat capacity. So molar heat capacity Cm equal to molar heat capacity. Cm means molar heat capacity equal to heat capacity divided by number of moles of the substance. Number of moles of the substance equal to heat capacity means already we know represents by capital C, heat capacity, by number of moles, so N. So molar heat capacity equal to heat capacity by number of moles of the substance. Units joules, mole inverse. So number of moles denominator na mole inverse, Kelvin inverse, or calories, mole inverse, Kelvin inverse. These are units for molar heat capacity. Next one, specific heat. Specific heat. Specific heat. Specific heat. It represents by small c. Small c. What is the specific heat? The amount of heat energy required for the rise of temperature of 1 gram of the substance. Molar heat capacity means temperature rise of 1 mole of the substance. Yes, specific heat means the temperature rise of 1 gram of the substance. 1 gram of the substance. So here 1 gram of the substance. 1 gram of the substance by 1 centigrade or 1 Kelvin. By 1 centigrade or 1 Kelvin. This is called specific heat capacity. So specific heat capacity C equal to small c. Small c means specific heat capacity. Specific heat capacity C equal to molar heat capacity. Molar heat capacity by molecular weight. Molecular weight. Molar heat capacity means Cm by molecular weight. MW means molecular weight. So specific heat capacity equal to molar heat capacity by molecular weight, or molar heat capacity by molecular weight. Units joules, gram inverse, Kelvin inverse, or calories, gram inverse, Kelvin inverse. Joules, gram inverse, Kelvin inverse. Calories, gram inverse, Kelvin inverse. This is about the specific heat. So finally, heat capacity means temperature rise of given amount of the substance by 1 centigrade or 1 Kelvin. Molar heat capacity means temperature rise of 1 mole of the substance. Molar means 1 mole. 1 mole of the substance by 1 centigrade or 1 Kelvin. Specific heat means temperature rise of 1 gram of the substance. 1 gram of the substance by 1 centigrade or 1 Kelvin. That's why C equal to dQ by dt. This is heat capacity, capital C. Cm equal to C by N. C by N. Next, specific heat capacity, small c. Specific heat capacity, small c. Small c equal to Cm by